Section 4.2, example number 2. Find the exact values of the following. The first one's pretty easy because remember that the domain of cotangent is all the numbers. It's the range that's restricted, right? And then the range of the actual cotangent function is all real numbers, and it's the domain that's restricted. So in other words, if we're plugging -5 into our cotangent, that's just fine because we can plug in anything. That's going to give us an angle, and then the cotangent of that angle is simply going to result in the ratio -5. So in this case, because it's an inverse first and the actual function second, the answer is also the input. It's like the inverse and the function cancel each other out, leaving us with the -5 input that was done in the first place. Now this one we have to be more careful with because we're not doing a tangent with an inverse tangent, otherwise the same rule will apply. This one is taking an inverse tangent and then finding the sine. So the first thing we need to do is focus in on what quadrant this would be. This one would have been quadrant 2, but that doesn't really matter because a cotangent of a quadrant 2 angle is also going to be negative with that same answer. So that didn't matter. But this one does matter for us to put it into the correct quadrant so that our sine value will have the correct positive or negative value. Okay, so here's a little triangle, and tangent is opposite over adjacent. So I'm going to put 3 here, 4 here. So 4 is positive because it's to the right. The 3 is negative because it's going downward because it's opposite over adjacent for this angle theta. And then in order to do sine, we need to know the hypotenuse. So we would use Pythagorean theorem. It's a 3, 4, 5 triangle because 3 squared is 9, 4 squared is 16. Add those together, we get 25, and the square root of that is 5. So that means that the sine of this angle is going to be -3/5. So if the question had asked for cosine instead, then the answer would have been +4/5. And if this had been an inverse cotangent instead of a tangent, we would have put it in quadrant 2, and then sine would be positive and cosine would be negative. So hopefully it makes sense why this one, the quadrant mattered, whereas this one it didn't matter because we were just doing a cotangent and an inverse cotangent in the same problem. This was a different one, so we had to be very careful of the quadrant to make sure we got the right sign on our answer. Okay, example 3. Rewrite the following as algebraic expressions of x to state the values of x for which they hold. So basically, it's finding the domain is what it's asking us to do. Alright, so for this first one, we start in the middle, remember? So basically, it's saying there is some value theta, so that the arctangent of x is theta. In other words, the tangent of this value theta would be x. So that means we can put theta in place of this, right? So essentially we're finding the tangent of 2 theta, which we can find by using the formula that we learned in section 3.2. 2 tangent theta divided by 1 minus tangent squared. Alright, so x is tangent theta. All we need to do is plug in x where we have tangent theta. That's it. The only other thing we have to do is find the domain. So heading back into what we learned in Math 1050, we just need our denominator to not equal 0, right? So 1 minus x squared cannot equal 0. Can't divide by 0. So I can factor this. 1 minus x, 1 plus x, can't equal 0. So for that to happen, that means 1 minus 1 would not work because that would make this 0 times 2. 0 times 2 is 0. We don't want it to be 0. And it also can't be negative 1 because 1 minus 1 would be 0, and 0 times negative 2 would be 0, right? Actually, this would also be a positive. Either way, these two values don't work. So this is our restriction on our x values. State the values for x for which this is true. Another way of writing this would be to say negative infinity to negative 1, negative 1 to 1. Oops, u, let's turn that into a u. And then 1 to infinity. So it's just those two values that don't work. Okay, next one. The inverse cotangent of negative 1 is 2x. Let's create a picture for this because we're finding the cosine, even though we're starting with cotangents. So we need to make sure we have everything in the right place. We're just going to use quadrant 1 for this. So cotangent, it might be helpful, at least to my brain, to switch this to a tangent instead. So since we're just doing quadrant 1, it doesn't matter whether it's cotangent or tangent. Okay, so 1 over 2x, so that would be opposite over adjacent. Then to find the hypotenuse, we would do a squared plus b squared equals c squared. So c would be the square root of a squared plus b squared. So that would be 2x, that entire thing squared, plus 1 squared, which gives us the square root of 4x squared plus 1. So that's the hypotenuse that would go there. Okay, great. I guess I can write it in there if I make my pen a little smaller. Square root of 4x squared plus. Okay, so then if we want to find the cosine would be of whatever this angle theta is. Cosine would be adjacent, which is 2x, over hypotenuse, which is 4x squared plus 1. Now to find the domain of this particular problem, we don't want the denominator to be 0, but we also don't want what's in the root to be negative. So what we're going to do is say that 4x squared plus 1 must be greater than 0. Because it can't be 0, even though we can take the square root of 0, we can't divide by 0. So then if we went ahead and tried to solve this, first of all, it doesn't factor. So we could solve it perhaps by taking and moving the 1 to the other side. Is it possible for something with a squared in it like this to have a negative 1 answer without it being imaginary? No, it's not possible. It would not be a real answer if it was greater than a negative 1. There's no way for this to be negative. So since there's no answers that make this true, nothing makes it true. Makes this true. The domain is all real numbers. Which generally we write as negative infinity to positive infinity.